Hi, in this video I'll be working out problems 1 through 4 on Test 2's test review. So, on a separate sheet of paper, 1 and 2 are long division problems, so we're going to start off with our divisor on the outside and our dividend underneath. Remember, you always need to make sure every term is present from your highest degree term down to your constant term. So if you didn't have a quadratic term, you would need to put in 0x squared. So we'll start off by dividing the first term in our dividend by the first term in our divisor. So x cubed divided by x, remember, means x times x divided by x gives you x squared, so we're going to line it up over our x squared term. Now we distribute this first term in our quotient by each term in our divisor. So x squared times x is x cubed, x squared times negative 8 is negative 8x squared. Next, we draw our line and change our signs. In this case, negative 8 plus 8 gives us 0x squared. It's still going to be important, even though it cancels out, to write the 0x squared to divide and get the next term. Next, we bring down our linear term and divide again. Be cautious here, because even though 0x squared divided by x gives us 0x divided by x, we're gonna need that term so that we don't mess up the last one. So 0x times x is 0x squared. 0x times negative 8, of course, is 0, but we'll put plus 0x. We draw our line and change our signs. It really doesn't matter if 0x is positive or negative because it's a non-negative number. 16x minus 0x is 16x. We bring down the 128 and start the process again. So 16x divided by x gives us 16, and that's our constant term. And we'll mess that up if we don't do the 0x, so that's important. So 16 times x is 16x. 16 times negative 8 is negative 128. But be careful here, when we draw our line and change our signs, we actually do have a remainder. These don't cancel out, and our remainder is 256. So we always write your remainder up here as plus your remainder if it's positive and minus remainder if it's negative. But 256 over the divisor, x minus 8. So that means our final answer, please write this quotient but without the 0x, would be x squared plus 16 plus 256 over x minus 8. And be clear when you write it to indicate that the 256 is over the entire divisor of x minus 8. Now, similar to how I taught you that 7 goes into 35 5 times, so therefore that we could multiply these two numbers to see if it equals our dividend, we're going to do the same thing. So now let's, in our calculator, go to y equals, and we're going to type our dividend into y1. Oops, I hate it when I do that. X to the third. Forget with this newer software on here, I can mess up exponents easy. Alright, so that's our dividend, and then in our y2 we're going to type in the product of our divisor, x minus 8, and then our quotient, x squared. I'm going to skip over plus 0x, plus 16 plus 256 divided by parentheses x minus 8, close, close. So remember, when you type this in your calculator, you need to tell the calculator that all of this is your quotient. However, in this remainder, x minus 8 needs to be in parentheses. So there's your parentheses to remind you where they go. When we check our table, if we've done this correctly, our y1 and y2 values will match up. Don't worry if you see one error, as long as all the other values match up, because if we go down here to 8, we'll see that error message. So that doesn't mean it's wrong. If all of our numbers are the same, then it's correct. Alright, so this is our answer for number 1. For number 2, we have 3x plus 1 as our divisor. Remember, anything to a negative 1 power, we talked about that being related to the rule, if you had a to the negative 1, your negative exponent law, that we could invert it and make it 1 over a to the positive 1. So this simply means that we could move all of this down here and be dividing by 3x plus 1 to the positive 1 power. So that's why 3x plus 1 is our divisor. So 3x plus 1 with our dividend being 3x cubed minus 5x squared plus 10x minus 3. So we've got cubic, quadratic, linear, constants. We have all of our terms, and we're going to do the same process. So let's take our 3x cubed divided by 3x. When we divide that, we get x squared. I'm going to line it up here on my x over my x squared term and distribute. X squared times 3x is 3x cubed. X squared times positive 1 is positive 1x squared. Draw my line, change my signs. Negative 5x minus 1x is negative 6x squared. I said that wrong. Negative 5x squared minus 1x squared is negative 6x squared. I'm going to bring down your linear term and repeat the process. So we have negative 6x divided by 3x, where the x's cancel, and negative 6 divided by 3 is negative 2x here. So now distribute. Negative 2x times 3x is negative 6x squared. Negative 2 times 1 is negative 2x. Draw your line, switch your signs. 10x and 2x make 12x. And then we're going to bring down our constant term and divide again. 12x divided by 3x is 4. So that's our constant term. Go back and distribute. 4 times 3x is 12x. 4 times 1 is positive 4. Draw your line, switch your signs. Negative 3 minus 4 is negative 7. So I'll put up here minus 7 over 3x plus 1. So when checking this, remember we want parentheses around all of this, but also parentheses around the 3x plus 1. Please do this on your test so that you can ensure that you have the correct answer when you turn it in. So 3x to the third minus 5x squared plus 10x minus 3. And then our divisor, 3x plus 1 times our quotient, x squared minus 2x plus 4, and then our remainder, minus 7 divided by parentheses, 3x plus 1, close, close. And we can see the y1 and y2 values do match up, so that makes me feel very confident. We have our right answer. X squared minus 2x plus 4 minus 7 all over 3x plus 1. All right. Now, for numbers 3 and 4, you're asked to evaluate the polynomials. It says by division. I'm not going to require division. I want you to evaluate using substitution. Remember to do that. We can simply store the value we want to evaluate in our calculator. So we're going to do 1 store as x. You do not change the number. If I had said to evaluate with a factor of x minus 1, then we would switch it to positive 1. But if our x value is 1, we store 1, and then we can simply type it in on our home screen. X to the third minus 3x squared plus 5x minus 3, and it equals 0. Well, that should tell us something interesting here. F of 1 is equal to 0. So for number 3, what I would want you to write as your answer, go ahead and put that you evaluated f of 1 equals 0. Then with a semicolon, you can separate your thoughts and to do this part, which is explain what the solution tells you about the polynomial. Remember that based on our factor theorem, if our remainder is 0, then that means that x minus 1 is a factor. So let's write that. So I taught you to write the statement. For f of x equals, and then just copy your function down. Then you can say x minus 1, and then tell me if it is a factor because it equals 0, or it's not a factor because it does not equal 0. So in this case, we would say that x minus 1 is a factor because, remember your inverted little triangle, the 3 dots, because f of 1 equals 0. All right. Then for number 4, remember, if we're evaluating f of negative 3, that means the factor would be x plus 3. but that means we are going to store negative 3 as our value. So negative 3 store as x, enter. Then just type the function in. 2x to the third plus 4x squared minus 5. And we get negative 23. So we know that f of negative 3 has a value of negative 23. So then we would state that for f of x equals 2x cubed plus 4x squared minus 5, that x plus 3 is not a factor because f of negative 3 is equal to negative 23 and not 0. Okay, and that would be our statement. And that concludes this video. The next video, I'll do problems 5 through 7.